All right, hello everybody. Welcome to the channel Software with Kevin Carr. I'm Kevin Carr. I'm actually starting a new video series called Anybody Can Code. So the origin, the name of the series comes from Ratatouille, with the book from one of the characters saying anybody could cook. I have the same belief that anybody can code. It's pretty, I wouldn't say it's easy. It's always going to be a journey to learn this, but after these series, I'm going to be interviewing the people who are self-taught, have gone to school for computer science. But essentially, as a software engineer, you're going to have to do some type of self-taught learning, improve your skills. So these are all going to be profiles of people who have taught it themselves or learned it like through a more formal background. But again, I just want to show you the power and effects that learning software, engineering skills, and programming skills can have in your life. So I would like to warmly introduce my friend Solomon Moon. He is currently working at JP Morgan in kind of a data science, data analyst field. But before I bungle that up, I'll just have him kind of introduce himself. So the floor is yours, Solomon.
Yeah, I appreciate you having me, Kevin. So I currently work at JP Morgan. I'm a senior analytics associate. We do a lot of data science stuff, use a lot of programming, a lot of automation, and pretty excited to be here talking to you.
Yeah, I appreciate you taking time to kind of discuss like your journey into coding and software engineering. So before we get into that, I'm just wondering if you kind of give like, if someone were to direct your movie, like the background, like what's the first chapter of you kind of getting into the workforce, and then that leading towards you learning to code as well.
Yeah, sure. So I got my bachelor's in economics at the University of South Carolina. Go Gamecocks.
Boom.
That's right. And so I actually did an internship at a company in the farm credit system, which is pretty massive. Like most people haven't heard of it, but it is a very massive system dedicated to farmers. And so I got an internship there, worked there for a little bit in a variety of positions. I did marketing stuff, I did business analysis stuff, and then finally I got a full-time job there as a quantitative analyst. And so through that role, we would produce a lot of things largely through Excel. And there's just that lazy part of me that was kind of like, it has to be easier than this, and so that led me to learning R. And so once I learned R, I kind of, automated a lot of things, and then just from natural curiosity got into Python.
So yeah, just quick, like a little point. I want to make sure, like for all the newbies who this might be their first programming video, like what is R?
Yeah, so R is a statistical programming language. It was created by a group of biologists, I believe, like probably about 30 years ago, approximately. And since then, it's grown into a pretty massive community. So, R allows you to do a lot of really great and very quick data analysis. It allows for really great model building. So it's a great language if you're doing anything with data.
When someone's recommended going down the data science or data engineering path, or at least like kind of dipping their toes into it, the two programming languages that get recommended the most are R and Python. So just because I know you had some experience with Python as well, what do you think the major differences are between those two languages?
Yeah, so Python is a general purpose language, right? Well, whereas R is a statistical programming language. So if you're going to learn one or the other, I would generally say learn Python first, because Python's a little easier to learn, and then Python's going to be more widely used given anything you want to do. Whereas R is really for, hey, I'm getting into data, I'm trying to analyze it, I'm trying to understand it, I'm trying to derive insights. So that's the big difference. So I personally love both. I think there's a place for both, but you can only really understand how to use both if you know both, if that makes any sense.
Yeah, like you definitely don't know what you don't know. And it kind of sounds to me like from your perspective that R is like a little bit more granular, like niche and specific for that data analytics purpose. And then Python, I know too, you can do a lot of like multi-purpose stuff. So not just data science, but making your own backend websites, scripting, like automated processes. And speaking of automation, I've like personally, and hearing from others, I know a lot of people have gone to programming that way. There's some type of manual process at work, and instead of like wasting all that time, like either doing manual entry or like formatting, like a lot with spreadsheets, they had that same idea, like how do I just save time? Because it can be a little bit, I wouldn't say soul crushing, but when you know you're wasting your time, you don't have to. It's definitely not a pleasant feeling. So I was wondering if you kind of go a little bit deeper into that project and how, not know anything, like how you eventually got into finding resources to learn how to automate that process.
Sure. Well, I will call it soul crushing if you want. It definitely crushed my spirit a little bit.
Mhm.
So the way I got into programming at first was I would take basically things we were doing in Excel, and I said, okay, let me recreate this in either Python or R. So that was my introduction. So like one thing comes to mind where there was a process we had at work where we were taking a data set and we were basically doing a whole lot of data cleaning. We were doing data removal, all kind of stuff. And this process happened over 3 separate spreadsheets because the data set was that massive, right? Well, the problem is if anyone's familiar with Excel, you would have a lot of issues where things would break, things wouldn't function properly, you wouldn't necessarily get the results you expected. At some point, we ended up spending, an hour, 2 hours, 3 hours just trying to validate the data that came from this process when it was Excel based. I ended up recreating that same process in Python. It literally took like 30 seconds. and it worked 100% of the time going forward. So it saves massive amounts of time. If anyone ever is like, should I learn this or not? Yes. The answer is definitively it's a yes.
I like how you pointed out that's not only just the time savings that you get, but also when you're able to automate like a process into a more procedure or step-by-step way, there's less opportunities for human error. So because we can make like a fat finger mistake like in a number, or maybe like a string isn't formatted correctly. I kind of had a similar experience too, like automating an Excel spreadsheet of customer feedback data, instead of having to do that all myself easily in a couple of seconds, running a script and everything's formatted appropriately, do all the data transformations appropriately. And once I think people kind of get that aha moment, they want to learn more and more like ways to either automate parts of their job or just save themselves a lot of time.
That's right. And so I know one of the big motivators for me was we were getting more and more audit related things because, these auditors come in from PwC or EY or whoever, and they go, but how do you know it's correct? But how do you know this works? And so when you move things to be programmatic, it's much easier to your point where it's like, hey, these are the logical steps that occur. This is how we validate it. This is how we put in change logs and controls. It's so much easier as opposed to something spreadsheet based. So like it saves a lot of time and aggravation and headaches from an audit perspective as well as from a general like productivity stance.
And it seems like, if you were to achieve those gains and pass it on to your team, like, not only like being very adherent to like audits, the time saving, the reduction of human errors, that your team's going to notice. There's going to be like metrics like, oh yeah, we're really improving as a team. So I'm wondering if you kind of like dig a little bit deeper into how maybe not mastering the language, but just kind of slowly improving your programming skills has affected your career.
Sure. I mean, so it's affected my career in a great way, right? I remember when I first graduated. You graduate from college, you're all excited and bright-eyed and bushy-tailed. You're applying to jobs, and you're not really getting a ton of callbacks. At least I wasn't. I had a few interviews. I didn't get as many offers as I felt like I should have, given how talented I thought I was. And then I remember, kind of when I decided to leave the farm credit system, I started applying. And it seemed like every other application I would get a callback from a recruiter where they'd go, hey, we'd love to talk to you. And even if I didn't get an offer, I at least was getting the exposure or the opportunity in an interview. So like just knowing these programming languages is big because these hiring managers, they look at that and they go, hey, this guy taught himself something. He clearly is bright. He clearly is capable. Let's bring him in and talk to him. So like that's been a big way. And then secondly, as I've transitioned into a separate company in a different career, I've seen for a fact that like a lot of these companies are using these tools. They're using R, they're using Python, right? They want you to know a programming language because that's where the world is headed. Yeah. So it's helped my career dramatically.
Again, you don't have to be like a master like programmer. If you can just automate little things, what you had mentioned with the ability to learn, with a lot of corporations and companies, like wherever you join, there's going to be like constantly changing like project requirements. Like, hey, I need you to do this feature. That ability to learn something like by yourself or learn something new, like it's going to further strengthen like your ability to learn other things, like or like kind of
that's right.
Develop your skills on the fly. So you're definitely right on.
And some of the best programmers I've seen, like they use StackOverflow all the time. Mm-hmm. So like they don't know everything off the top of their head. They look at the community to see what other people have come up with. because like the best thing about these languages is that they're open source and that there is a wide community that can help you and assist you in understanding and learning new things. Because like you could give me a problem and I could come up with a solution, and the solution will work. It'll work just fine. But I could also go online or go to the community, and they may come up with a better solution. And now I'm now a little bit smarter than I previously was in terms of how I address this specific problem. So
Yeah.
it's a great thing.
Yeah, I think that's a very good concept to like at least be aware of too, because you shouldn't have like this mentality that other programmers are automatically writing everything from scratch. They're not looking at anything; it just like comes from their mind. It's almost like art. Like if you're getting into drawing, you might think people are just imagining and drawing it from memory or from their imagination. A lot of times, good artists, they'll use references. So like maybe like a picture of someone standing a certain way in like or certain motion to like capture that movement. So it's the same thing with programming. You can look at other people's code to get, or maybe just blog posts talking about like an architectural, their software architecture, and get good ideas. So as long as you're continuously like learning and kind of just adopting those best ideas, I think you can go far. Especially if you're humble enough to realize that you're not the best coder.
Absolutely.
Yeah. Just for like people like getting into software engineering, and when you were first learning, what do you think were the best resources to actually learn those skills you needed for the job?
Yeah, sure. So this is gonna to some degree depend on what language you're trying to learn. So if you're learning R, which again, if you work in anything where you're doing data analytics or business analytics or data science, I think R is a great language to start with.
Yeah.
It's a little more complicated than Python, but it's a great language. Read anything by Hadley Wickman. That's R for data science. Anything that guy writes, read it.
Okay. And I'll make sure to add those book recommendations into the description of this video as well.
Oh, please do. And so if you're learning Python, one of the things I think is a great resource is I love DataCamp for Python.
Mm-hmm.
And it's not because it teaches you exactly what you need to know. It's because it gives you an understanding and a sense of the universe. Mm-hmm. So like you may come across something on DataCamp where it's like, oh, okay, that's a good thing to kind of keep note of. And then you experience a problem in real life and you're like, oh, man, that thing I saw in DataCamp, that could be useful. And then that gives you a reference point to learn more, to dig a little deeper. So DataCamp is great for Python. And of course, YouTube, right? Yeah. YouTube's amazing. So if you ever have a question or a solution or a problem and you need a solution, YouTube it. Someone's figured it out, I guarantee you.
I definitely agree. I actually just invested in YouTube Premium because I was tired of the ads and I just wanted to get like the actual content. So, speaking of YouTube, are there any specific YouTubers you would recommend for like specific data science learning? Because I know you recommended a business analyst, YouTuber, but there's also some other YouTubers you probably like would recommend to follow as well.
Oh, absolutely. So there's a woman called Come Up. She does some pretty good stuff. There's another guy, if you're more interested in like a data analyst type role, his name is called Alex, the data analyst. I like a guy whose name is simply Python for programming. There's Richard on data. Yeah. There's Alex NG. I'm not sure how to pronounce his last name, so I don't want to butcher it. So there's a lot of great channels and great resources. I also, like, just as a side note, there's a great blog for anyone who's learning Python and works in a business setting. It's called PB Python, which is short for Practical Business Python. Okay. Yeah, like he does a lot of different use cases for Python in a business sense, and like great blog for anyone who's interested. Honestly, I think that's one of the best resources I've had.
I think I've actually used that blog to figure out like some Excel library like automation. So definitely a great blog. I'm wondering for yourself, with the current skills you have, where do you see yourself, like what type of problems you want to be working on in the next 5 years? Like,
yeah, so I'm actually really excited about analytics right now, just because for me, analytics is the nice crossroad between model building, between like descriptive analysis, and between visualization. All three are things I like to do, but I don't like to do too much of any one of those, right? I don't want to spend all my time building models because that bores me terribly if I do. I don't want to spend all my time building visualizations, and I don't want to spend all my time cleaning data. So I really like analytics. I think my end goal is to kind of keep progressing in my current role and maybe become a VP at my current company or manage a analytics team externally or something like that.
What kind of emerging trends do you think you have a hypothesis about?
Yeah, so that's an interesting question, right? Because there's a million things that could happen. When I kind of look at the industry as it currently stands, I see data quality becoming a big trend amongst most companies. So companies have aggregated data over the last decade or so. Now they're really focusing in on how clean is the data? How much insight can we really derive from it? So I think data engineering is going to be massive, continue to grow, right? It's already pretty big field. It's going to continue to grow. So anyone interested in data, look into data engineering. It's going to get you paid and you will be employed. I also think that, we're kind of seeing this weird trend where I think we're going to reach a point very soon of machine learning producing diminishing returns, right? Because right now you're getting a lot of companies that are they're scaling their machine learning capabilities up greatly. But you're going to hit a certain point to where you're really taking on a lot of these machine learning projects where it just isn't a good use case for. And I've seen some of that just professionally, won't go into details for a number of reasons. But over time, I think there's going to be a big emphasis on really understanding what use cases go with or are best suited for machine learning and which aren't. And so I think traditional quantitative modeling is going to make a comeback.
Mm-hmm.
I think that AI is going to be a little more fine-tuned than it currently is. And you're going to see a lot more streamlining and a lot more fragmentation in terms of products that are used, whether it be a data robot or an Outtro and so on.
When you only have limited tools, so like a hammer, you think everything, every problem is like a nail, and you can solve that. So are you essentially recommending for different data cleaning and engineering techniques to kind of just expand the breadth of tools that you have available to you and a little bit more nuance into determining which tools to use for the particular problem?
So absolutely. So I think before you can get to that point, it's very helpful to go back to basics, right? Because there's such a lack of emphasis on the design of things, mm-hmm. where a good design will take you very far, right? If you design your data infrastructure very well, then having clean data enables you to do a ton, right? And so yes, there's still places where machine learning and artificial intelligence come into play, but there's less places that they're needed because you have a good infrastructure and because you can do a lot more with clean data than not having clean data, right? So I think people need to kind of go back to the basics, take a step back, and figure out, hey, what does our data look like today? How can we actually gain insight from it? And then from there, you can start, gaming out use cases.
But how did you personally improve those design skills where on the outset of a new data project, whether it be more predictive or analytic and visual, determining how to structure that data from the start?
For starters, it's a lot of trial and error, mm-hmm. right? It's a lot of making mistakes and failure. But you also can't be afraid to go to people who understand the data better than you, typically business owners in that particular segment of the data, and talk to them. I think, I see so many people who are afraid to engage with other people outside of their small world. And you can't do that. If you really want to understand the data, you have to go to this line of business and say, hey, listen, this is kind of what I'm seeing. Can you explain to me and walk me through how your business works? Because if you actually sit with the business owner and you actually see how their day-to-day looks a lot of the times and how the data actually gets created, that gives you a lot of insight to the shortcomings of the data. Okay, I know what's being captured here. I know what's not being captured here. I know what room, what manual errors may be made in terms of creating this data. So you can really then get a feel for it. So that's my biggest thing, is just talk to the people who are actually in the line of business, get an understanding of what they're doing, how they're doing it, why they're doing it. And then from there, you can really start to drill into the data and understand how it's derived.
I think that's a very important concept too. As a software engineer, you're not just getting paid for code, but to actually understand the problem and communicate with others. So it's almost like you're finding a product market fit for your data and making sure it's relevant, and you're building something taking weeks and you find out, well, a simple conversation could have prevented that.
And I've observed that too.
Yeah, I mean, me too. So I think the communication is key. really, it's almost like treating whatever project you're working at as like a consultant. Like really find the basic problem, understand the goals and the definition of the problem in order to adequately build a solution for that, rather than the solution you think is going to address the problem.
That's right. And you know what's crazy? So I see so many people who like start working with the data set without doing any type of exploratory data analysis, which is like insane to me, right? It's like, because your first step should always be to like get a data set, no matter how well you think you do understand it. It's like start with visualizing it, start with summary statistics, start with looking at outliers, start just feeling your way around it. And I see so many people like take these data sets and not do that, and they just jump in and start trying to build a solution. And it's like, you can't do that. Don't do that.
Yeah,
people watching, don't
definitely.
Do that.
Tisk, that's bad. From your years, kind of in the programming, like finance, like field, when you've done that data validation and exploration, what? And you don't have to get too specific, because I obviously know it's from different employers, yada yada yada. But can you tell me a time like where your initial assumptions on the data was completely invalidated by actual exploration?
Yeah, sure, man. So I remember one time we were kind of looking at like at a certain place I was working at, we were looking at rebuilding our prepayment model. Mm-hmm. And so, you know, the way we were thinking about it is like, hey, we expect in these economic conditions, we would observe X happening, right? And so you get into the data and you start seeing like, oh, no, that doesn't hold true at all. You don't see a stronger relationship between the economy and these specific types of prepayments as you would expect. Once you see that, it's kind of like, well, what's going on then? You know, why are we actually seeing that? And then you start trying to drill into it and understand why you are actually observing the relationship you observe and trying to come up with new hypotheses. So that's a time that comes to mind. But, you know, I'm sure there's plenty others. If you're someone who's a newcomer, your number one responsibility is to not make assumptions, mm-hmm. right? Because it's so easy to have a bias when you build something and you develop something and then it gives you a result. Well, because you built it, it's easy to go, yep, I built it. I'm flawless. I make no mistakes. Like, it's working as intended. You know what I mean?
Just walk off.
That's right. You know, it's easy to do that. And I see that happen all the time. So, like, don't carry that assumption that you're perfect into your program, into your model. Don't do that. If anything, like, build a model, develop it, and then really sit and go, but what are the shortcomings of it, right? And don't be afraid to take that model to people who are not like you and try to talk to them about the problem you're trying to solve, because chances are you're going to get a perspective that you don't currently have. And that then can inform the model you're trying to develop. I think people far too often undervalue the role of just talking to other people. Like, we don't, you know, we undervalue that these days because it's so easy to text and tweet and send a comment on a DM and all that. We don't
slide in those DMs.
Discuss things anymore.
So just imagine you're on an elevator and you have 30 seconds to convince someone else to learn how to program. What would you say?
Ooh, that's a good one. Yeah, so my pitch would go something like this. I'd say, listen, the future is heading this way, right? It's like, if you look at job postings, jobs 10 years ago you didn't need to know code for, you need to know it now. Not only do you need to know it, but it makes your life better and it makes your life easier. It's like things are more accurate, things work faster. And then, you know, my last point would be coding is actually a lot of fun. Like, yeah. It is a lot of fun. Who doesn't like solving problems? It's like, do you like puzzles? Do you like Sudoku?
Yeah.
Coding's no different.
Or like strategy games like League of Legends, or
there's Rome Total War.
Yeah, definitely.
Yeah.
Well, Solomon, thank you so much for being the first guest on this YouTube video series. I just want to give you the floor for however long, if you want to plug your social media handles, just talk about something. The floor is yours, and thank you too.
Nah, Kevin, thanks for having me, man. I've known you a long time. You're absolutely brilliant. I appreciate you having me. Like, I guess you consider me smart too. I appreciate it, man. Anyone who's out there, feel free to add me on LinkedIn. My name is Solomon Moon. You'll find me. Very unique name. You have no trouble finding me. Anyone has any questions or needs some help finding a job or anything, I'm more than happy to help. So
sounds perfect. Well, thank you again, and I'm sure we'll be collaborating on more videos together too. So thanks again.
Hopefully, man. No problem. Take care, Kevin.
All right.